So what we're looking at today is we're just continuing on what we did last week, last Thursday, Friday, multiplying these rational expressions. And I wanted to finish this up and do these here so we can get see a few more of these and see how these work. So what we're going to be multiplying or at least to start today, are these two here. So we have c to the third plus 8 over c to the fifth minus 4c cubed times c to the sixth minus 4c to the fifth plus 4c to the fourth over c squared minus 2c plus 4. So we're multiplying all of these together. So we're going to have two things being multiplied together. Now, the first one we can look at is our c to the third plus 8. That's the first one on top that we have. Well, if we look at this here, c to the third and 8 are both perfect cubes, yes? Because I can take the cubed root of c to the third, and if I take the cubed root of 8, I get what? 2, yes? So this is the sum of perfect cubes. 3 and 5. Now our signs are going to be the same, so plus, opposite, always end on a positive note. Plus, minus, plus. Same, opposite, always end on a positive note. Now our cubed roots that we would have been c and 2. Those are our two terms. So plugging in the first spot, well, we would have c, then we would have c squared and c. In the other place, well, we would have 2. In the middle, we would just have 2. And the last spot, we would have 2 squared. So we're filling in this sum of perfect cubes. Now, we'll eventually need to simplify this here, especially with this middle section, because we have 2 squared and 2 times c. So we'll rewrite it so it looks a little bit nicer. But we have this here. Okay. So it takes care of the top of the first fraction. Now the bottom of the first fraction is we have c to the fifth minus 4c cubed. How can we factor this one? What can we do? Yes, it does have a greatest common factor of c cubed, c to the third, and we can factor it out of both terms. Now, if I factor c to the third out of c to the fifth, I'm left with c squared minus, well, we didn't do anything to the 4, so it stays. And c cubed, factor out of c cubed, factors out completely. So we're left with c squared minus 4. Is c squared minus 4 factorable? Yeah, it's a difference of perfect squares. So we'll factor that in a minute, because we're going to have to rewrite it again anyway. So we'll factor that on the next step. Okay, let's look at the top of the second fraction. What can we do to factor it? What's one of the first things we can do? Yeah, we can factor out a c to the fourth. There is a c to the fourth in common in all three terms. So we can factor out that greatest common factor. C to the fourth factored out of c to the sixth, well, that leaves me with c squared. Minus 4, because we didn't do anything to the numbers. Now c to the fourth factored out of c to the fifth leaves me with just c plus 4, because c to the fourth factors out completely. Well, again, c to the c squared minus 4c plus 4, this here most likely is going to be factorable. Now let's look at the last spot. C squared minus 2c plus 4. So we need to see if this thing is factorable. So if we do this here, well, the 4, since it's positive, tells me the signs are the same and they match the sign of the middle term, yes? So we'd have minus and minus. Factors of c squared are going to be c and, now the factors of 4 are going to be 1 and 4 or 2 and 2. 2 and 2. And if we check this, c times negative 2 would be negative 2c. Negative 2 times c would be negative 2c, which gives us negative 4c. Is that what we wanted? No. So what can we try? So we can try c minus 1 and c minus 4. So let's check this. C times negative 4 is negative 4c. Negative 1 times c is negative c, which gives us negative 5c. Is that what we wanted? No. Are there any other things that we can try? Well, no, right? And if we checked it, it works out that this here is not factorable. This here works out to not be factorable. So it works out c squared minus 2c plus 4 will not factor. Okay, let me give myself a little bit of space. Okay. All right. Now, as we noticed after that first step, there were still a few things that we could factor, a few things we could simplify, yes? Okay. So if I look at the top fraction, well, c plus 2 is good. Our other one, well, we have c squared minus, well, 2 times c is 2c, yes? And 2 squared is 4. Well, wait a minute, doesn't that match with this here, c squared minus 2c plus 4? Okay, that's kind of nice. Now the bottom of this first fraction, c cubed, well, we know c squared minus 4 will factor. Now what will it factor to? Y'all remember? C minus 2 and c plus 2, because it's a difference of perfect squares. So we get the same values for the first and second term, both terms. It's just the signs are opposite. Over here, we have c to the 4th. Now, c squared minus 4c plus 4. We know that this will factor. Now, because the 4 is positive, the signs are the same, so we'd have negative and negative. The factors of c squared are going to be c and c. Now, what factors of 4 are we going to use? 2 and 2. Because we did this one a minute ago, didn't we? C minus 2 times c minus 2. And when we multiplied this together and checked it, we found that the middle term was negative 4c, yes? So this is the factors. These are the factors. Now, lastly, we have c squared minus 2c plus 4. All right. And what are we going to do? We're going to multiply these together, yes? I'm being lazy. I don't know about y'all, but I really don't feel like rewriting that whole thing again. Do y'all? No? And really, because when we look at this here, well, we move it all together and then simplify what's on top and bottom that are the same, yes? So why don't we just do it here because they are multiplied straight across. What's on top is going to be on top, and what's on bottom is going to stay on bottom. So what's in common? So these are in common, yes? What else? C minus 2 and c minus 2, those are gone. C squared minus 2c plus 4 is in common on top and bottom. Anything else? Because we have c to the fourth and c to the third on top and bottom, yes? So 3 of the ones on bottom will cancel with 3 of the ones on top, yes? Or if we were doing it also, since the bases are the same, we subtract the exponents. So 4 minus 3 would be what? 1, yes? Which one was bigger, the one on top or the one on bottom? Top, so where's it going to stay? On top. So the ones on bottom cancel out completely, and I could mark this out and rewrite it as a 1 because that's how many we have left. So looking at this here, what's left on top? Times. What's left on bottom? Well, 1, yeah, but everything else simplified out, yes? So what's our answer? This here. Now again, as I mentioned on Friday, this is just the mathematician in me. I would want to list every single possible value of c that would cause the denominator to be 0, but the homework is only going to really ask for ones that are kind of been canceled out. So if we look at this here, well, in the denominator, we had c to the third, c minus 2, c plus 2, and c squared minus 2c plus 4, yes? We had 4 different terms. Now, before we get to these first 3, c squared, c minus 2, and c plus 2, I want to look at c squared minus 2c plus 4. Well, where did we see that? We saw it right here as part of the sum of perfect cubes, yes? Now, I said, and we went over this the first time, I said that this thing here, would this ever be factorable? Well, no. The quadratic that comes out of a sum or difference of perfect cubes is never factorable. Well, if it's not factorable, does it have zeros? Well, no. Because if it is a factor, factors help us find the values of x, which would make the function equal 0. So if it doesn't have factors, which means it won't equal 0, can I have a value of x that's going to make this thing equal 0? Or value of c, sorry. Well, no. So this here, this part here would never equal 0, correct? So can I have any restrictions with this here? No. There are no restrictions with this here because it's not possible. There's no way for this to equal 0. So it is possible to have quadratics or have things in the bottom of a fraction that will never equal 0. Normally, these are the ones that give us imaginary solutions. But what we do have to look at is our other 3. So c to the cube, well, what value of c is going to make that equal 0? 0. c minus 2. Positive 2. And lastly, negative 2. For the most part, when we're adding or subtracting numbers, we can just take whatever that number is and flip the sign. Because c minus 2 is going to be positive 2. C plus 2 is going to be negative 2. Okay. Questions on this here? We feel okay with this here, even though we had some cubes and had to do a few more steps. Okay. I want to do one of these here, and we'll see how we feel after this. So I skipped that 124. We'll come back to it if we want, if y'all, we'll see how it goes. So looking at this here, we want to find the product of these two here. Yes? So we have x plus 2 over x cubed times 27. So we have that there. Now up to this point, we've been multiplying. Yeah, I'm going to need a bigger space on the first one. But I notice x cubed minus 27 is what? difference of perfect cubes. So I'm going to need some space. So we have top and bottom. Well, x plus 2, we can't really do anything to, correct? So we can factor x cubed minus 27. We'll do that in a minute. But wait a minute. The x squared plus 3x plus 9, that's not a fraction. It's not written as a fraction, is it? So does it have a denominator? Does it have a bottom? 1. Mm-hmm. So really, we could write it like this here. We can put the bottom of that fraction as 1. You don't have to write it this way, but it's sometimes helpful for us to just be able to picture it and see what's going on. Well, now we can factor. Let's start with x cubed minus 27. 3 spots and 5. Now, what are our signs going to be for this here? Yes. 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 Same, opposite, always end on a positive note. Now we can take the cubed roots of x cubed and 27, and that would give us x and 3, because the cubed root of 27 is 3. Now if we plugged in our first terms, x, well, we'd have x, it would be x squared, and then we would have x. Now if we plugged in our second term, the 3, well, the first one will have 3. 3 squared. Well, what is 3 squared? 9, right? This here would be x squared plus 3x plus 9, yes? Wait a minute. Is that what that is there? Those are the same, yes? So is x squared plus 3x plus 9 factorable? Well, no, right? Those aren't factorable. So there's a, would I even want to factor it? Well, no, it already matches up with what's on bottom, yes? Well, heck, if I have two quadratics that already match up, because we're trying to see what's in common on top and bottom, if they're the same on top and bottom, they simplify. Well, heck, if a quadratic's the same on top and bottom, why factor it? Because they're going to cancel out completely. So why do anything to it? Mm-hmm. Okay. Okay. We're going to do 2 steps in one. Because one, we can re-multiply these together. Yes, the tops can multiply together. So I'm going to have x plus 2 times x squared plus 3x plus 9 over x minus 3 times x squared plus 3x plus 9. So we did 2 steps because, well, we simplified part of the difference of perfect cubes, and we wrote it on one factor, or one fraction. What's in common on top and bottom? Which just leaves us with x plus 2 over x minus 3. Now, the mathematician in me would say, what is our restriction for this here? What can x not be? So it can't be 3, because the denominator here, 3, would make x minus 3 equal 0, yes? Well, we said this part of a sum or difference of perfect cubes is not factorable, correct? So there's no way to get a real 0 from this. So that means the only restriction is x equals 3. And most likely on this one here, because there's no other restrictions, because all the restrictions that we do have are already kind of still left there, it's not going to ask for it because we can see what the restrictions are. None of our restrictions were canceled out or simplified out. And that's it. Questions on this here? Do y'all want to see another example of one of these? Okay.